Hello students, today we are going to discuss the concept of the when the circle touches the coordinate axis. We have to see this concept. First we have to find the length of the intercept made by the circle on the coordinate axis. That is if a circle is given, then what is the intercept made by the circle on the coordinate axis. See this, if s is equal to the general equation is given here, x square plus y square plus 2gx plus 2fy plus c is equal to 0, with the circle intersects x axis, then the length of the x intercept is equal to 2 into root of g square minus c. This is the length of the intercept made by the circle on x axis. Now we have to prove this theorem. See that proof is so we have taken the circle, that circle intersects the x axis at 2 points. Suppose we have taken the intersecting points is capital A and capital B. If this circle intersects the x axis, then the coordinates of A and B, the coordinates of y coordinates of A and B are 0. So this is the proof. Since the given circle intersects the x axis, that is at A and B, then in these coordinates y coordinates are 0. On the x axis y coordinates are 0. Now put y is equal to 0 in the given circle. Y is equal to 0 in the given circle. X square plus y square plus 2gx plus 2fy plus c is equal to 0. We have to substitute y is equal to 0. Then the equation becomes x square y square will be 0 plus 2gx plus 2fy. Here y is equal to 0, that will be 0 plus c is equal to 0. So then the equation becomes x square plus 2gx plus c is equal to 0. So which is a quadratic equation in x. So here x coordinates are real and y coordinates are equal to 0. So the roots of this equation x square plus y 2gx plus c is equal to 0. So these roots are real roots. Since x is real, so here delta is greater than 0. That is for this equation b square minus 4ac is greater than 0 since x is real. So it has two equal roots, say x1 comma x2. So that is the meaning a coordinates are x1 comma 0 and b coordinates are x2 comma 0. Now we have to find the length of AB, that is the intercept of the x axis that is made by the circle. Now I have to find the x intercept, that is modulus of x2 minus x1. That is we have to find here, that is the length of the x intercept made by the circle on x axis. Here we have to take in the roots are x1 comma x2. x1 x2 are the roots of the quadratic equation x square plus 2gx plus 2gx plus c is equal to 0. So this is quadratic equation. It has two roots x1 comma x2. Now I have to find the sum of the roots. So what is the sum of the roots? x1 plus x2, that is equal to minus b by a, that is minus x coefficient by x square coefficient, that is minus 2g by 1, that is minus 2g. Therefore x1 plus x2 is here minus 2g, and product of the roots is x1 into x2. So here product of the roots is c by a, that is constant is here c, and x square coefficient is 1. So x1 x2 is equal to c, and we have to x1 plus x2 is equal to minus 2g. So we have x1 plus x2 and x1 x2. Now we have to find the modulus of x1 minus x2 or x2 minus x1. That is our required length AB. That is the nothing but the length of the intercept is modulus of x2 minus x1 or x1 minus x2. That is equal to the formula. What is here using the formula? Modulus of a minus b is equal to root of a plus b whole square minus 4ab. Using this formula, we are writing here modulus of x1 minus x2 is equal to root of x1 plus x2 whole square minus 4x1 x2. So here we are knowing the x1 plus x2 is 2z and x1 x2 is c. We are substitute in the above values. X1 plus x2 is 2z and x1 x2 is c. Here substitute, then x1 plus x2, that is 2z whole square, that is 4g square minus 4x1 x2, x1 x2 here c, so that is 4c. So we are getting root of 4g square minus 4c. So from that we are to common the 4, then we are getting 2 into root of g square minus c. So that is the length of the x-intercept. So therefore x-intercept of the given circle is 2 into root of g square minus c. Next, similarly we have to find the y-intercept. In the similar way, we have to find the y-intercept that is equal to 2 into root of f square minus c. Same like that, in that given circle equation, put x is equal to 0. On the y-axis, x coordinate are 0. Now we are taken x is equal to 0 in the given equation. We are getting the circle equation, second degree equation, x square plus 2f y plus c. So we are taken y1, y2 are the roots of the equation. Find y1 plus y2 and y1, y2. In the similar way, we have to find modulus of y1 minus y2. From that we are getting the y-intercept is 2 into root of f square minus c. So these are the intercepts made by the circle on the coordinate axis. So here, well known the formulas. X-intercept is 2 into root of g square minus c and y-intercept is 2 into root of f square minus c. Next, note these points. Here we are finding the x-intercept and y-intercept. In that, what is x-intercept formula? 2 into root of g square minus c. If g square minus c is equal to 0, the x-intercept will be 0. That is, in the coordinates of a and b, x1 is equal to x2. That is, x coordinates coincided, then the points a and b are coincided. Therefore, in that case, the circle touches x-axis. That is the condition here. G square minus c is equal to 0, then the circle touches x-axis. Or another way, g square is equal to c, then the given circle touches x-axis. If you given any circle, what do you say? The circle is touches x-axis or y-axis. We have to find g square and c. If g square is equal to c, then the circle touches x-axis. If f square is equal to c, then the circle touches y-axis. If g square is equal to f square is equal to c, then the given circle touches both the axes. So these are the three cases. If g square is equal to c, then the given circle touches x-axis, and if f square is equal to c, then the given circle touches y-axis, and if g square is equal to f square is equal to c, then the given circle touches both the x-axis. These we are seeing in these figures. The first case is if g square is equal to c, g square is equal to c, or g square minus c is equal to 0. In that, x coordinates of the intersecting points x1, x2 are equal. Then the given circle touches x-axis. See the diagram. This is x-axis and this is y-axis, and this is the origin. Now the circle, given circle touches x-axis like this figure. Next case, if f square is equal to c, that is nothing but f square is equal to c, or f square minus c is equal to 0. In that case, the intersecting points y coordinates are equal. That means the y coordinates are equal, then the intersecting points a, b are coincided. Then the circle touches the y axis. then the circle touches the y-axis. See this figure, this is x-axis and y-axis, and this is the origin, and the given circle touching here y-axis. These are the two cases. Next, third case is if g square is equal to f square is equal to c. In that case, the given circle touches both the coordinate axes. So this is the x-axis, this is y-axis, and the origin. The given circle touches both x-axis and y-axis. So in this case, the given circle touches both the x-axis and y-axis. Next, in this case, both x-axis y-axis touches the circle, then the coordinates of x and y are equal. That is nothing but the distance from center to x-axis is equal to the distance from center to the y-axis. Therefore, the coordinates of C are equal. Now we have taken that it be A, then the coordinates of C is A comma A, and the radius is also A, and here the radius is also same as A. So if any circle touches both the x-axis and y-axis, then x coordinate and y coordinate of the center are equal and is also equal to the radius. So that is the condition. If any circle touches both the coordinate axis, then center coordinates are a comma a and also radius is a. Note that this is the formula for the circle touches the both the x-axis and y-axis. So this is the we are taken general. If any circle touches both x-axis and y-axis, then the general equation of the circle is x minus a whole square plus y minus a whole square is equal to a square. So it is in the first coordinate. If the circle is in the first coordinate, then the required circle is of the form x minus a whole square plus y minus a whole square is equal to a square. If the circle is in the second coordinate, what is the circle form? That is x plus a whole square plus y minus a whole square is equal to a square. Since the coordinates of C is we are taken minus a plus a. I like that in the third coordinate minus a and minus a are taken center and radius is a. If the circle is touches both x-axis and y-axis, that is in the fourth coordinate, then their center coordinates are plus a and minus a. X coordinate is plus and y coordinate is minus. Like that we are taken the circle in which coordinate the center is plus or minus a and plus or minus a. We are taken plus or minus a we are taken. So like this we are taken the formula. If a given circle touches both the coordinate axis, so this is we have to note here. The circle is in the first quadrant. If the circle is in the first quadrant, then the circle equation is of the form x minus a whole square plus y minus a whole square is equal to a square. That is x coordinate, y coordinate are equal and also radius is equal here. Now next we see the problem along this concept. What is the here problem? Find the equation of the circle touching both the coordinate axis and passing through 2, 1. So this is the our problem. This problem is very important in MSET and JEE. See this concept. What is the here problem? Find the equation of the circle passing touching the coordinate axis and passing through the point 2, 1. Required circle passes 2, 1 and touching x-axis and y-axis. So this is the here the given problem. Now we are solving this problem. Solution is now here the given circle touches both the coordinate axis. Since the required circle touches both the coordinate axis, then the equation of the circle is of the form. In the above we are saying that the form is x minus a whole square plus y minus a whole square is equal to a square. Since the required circle passing through the point 2, 1, that point is in first coordinate. Say So the circle is also in the first coordinate. So given point is in which coordinate, then the circle is also in the same coordinate. Since the circle touches both the coordinate axis. Here given point is 2, 1. So 2, 1 is the point in the first coordinate. So the circle is also in the first coordinate. So we are taken the required equation of the circle is of the form x minus a whole square plus y minus a whole square is equal to a square. That is, we are taken the required equation of the circle. Next, we will see the diagram. This is the x-axis and this is y-axis. This is the required circle, touches both the x-axis and y-axis. This is the origin. This is another circle. So here the required circles are 2. Why 2? The required circles are passing through the point 2, 1 and touching the both the coordinate axis. See this diagram. So the required circles, there are forming here 2. So this is the point 2, 1. Now the required circle passing through 2, 1. So we are getting one small circle and another is a bigger circle. These two circles are passing through the same point 2, 1 and touching the both the coordinate axis. So here center is a, a. Since the circle touches both the x-axis and y-axis, the center is a, and is also radius is a. Now the required equation passing through the point 2, 1. So we are taken the required circle here, x minus a whole square plus y minus a whole square is equal to a square. In that we are substitute 2, 1. Then we are this equation becomes. So 2 minus a whole square plus 1 minus a whole square is equal to a square. In the place of x is 2 and in the place of y is 1, here substituting. And we are expanding this. We are expanding this. Here 2 minus a whole square, that is 2 square, that is 4 plus a square minus 2 into 2a, that is 4a, plus 1 square plus a square minus 2 into a into 1. So we are expanding these two. RHS is a square as is we are writing here. And simplifying this, we are getting a square minus 6a plus 5 is equal to 0. Now we are factoring this quadratic equation. This equation this can be written as a square. This 6a can be written as here 5 minus 5a minus a plus 5 is equal to 0. Here a is common, then we are getting a minus 5. Here minus is common, a minus 5, that is equal to 0. We are getting a minus 5 into a minus 1 is equal to 0. Then what is a is equal to 5 is one value and another value a is equal to 1. So these are the values of v. These are the values of a. So if a is equal to 1, that is the radius is a smaller circle. If a is equal to 5, that is the bigger circle, radius is 5. So we are getting the two circles. These are passing through the point 2, 1 and touching both the coordinate axis. So the required equation of the circles are, now we have to substitute a is equal to 5 in this required circle equation. We are getting x minus 5 whole square plus y minus 5 whole square is equal to 25, that is 5 square. Or another y value substitute, we are getting the equation x minus 1 whole square plus y minus 1 whole square is equal to 1. So these are the two circles or the required circles. See again the diagram. This is the x-axis and this is y-axis, and one of the circle touching the both the x-axis and y-axis and passing through the point 2, 1. And also another circle, bigger circle, that is the center is at 5, 5 and radius is also 5. The smaller circle center is 1, 1 and radius is also 1. So this is the required circles. These are the two required circles in that given problem. So one is a smaller circle and another is a bigger circle. These are the two circles the passing through the point 2, 1 and touching the both the coordinate axis.